Okay, picking up where we left off yesterday, where I asked you guys to just put this to the side and hold on, okay? Okay, the first thing that I'm going to do is I'm going to take out a GCF. Okay, I want to work with as small of numbers as possible, okay? So that's going to give me x squared minus 5x minus 72 equals 0, okay? Okay, what I'm going to do right here, I'm going to type this equation, the one without the GCF, I'm going to type this into Desmos. I've got x squared minus 5x minus 72. All right, so what I'm doing right here, I'm looking for my x-intercepts, and I end up with two really ugly decimals, which tells me I probably would have had to use quadratic formula to get that. All right, but let me ask you something real quick. If I am solving for my side lengths, okay, now if I get these two solutions, okay, if I get those two solutions, do both of them make sense? What am I talking about? I'm talking about side lengths of a triangle, right? Can I have a negative? Can I have a negative length? No. No. So I am going to cancel this one out. So I know that my side length is 11.346 for that first side. What would the other leg be equal to, or approximately? If this is that 11.346. 6.346. Okay, what did I do to that? Yeah. These are my leg lengths right here. Okay, and that's what I was looking for. All right, so this did not factor. I got an ugly set of solutions, okay, and I canceled out the solution that gave me a negative side length, and then I used my positive one to find the other length. Good morning. Did you check in the front? Yeah, you gotta go do that. My browsing disabled. All right, here we go. I'm going to minimize Desmos until I need it again, okay? All right, I need your conversations to stop, okay? We've been rocking along for the last week. Here we go. One leg of a right triangle is 8 feet, and the hypotenuse is 10 feet. Find the other leg. All right, it doesn't matter which side you put this on, okay? I'm just going to call this X. What am I going to use to find that? So X squared plus 8 squared equals 10 squared. So that's going to be x squared plus 64 equals 100. So what is x squared going to equal? Okay. Now, when I go in and I take the square root of both sides, technically I get plus or minus, right? But does the negative make sense here? No. So it's going to be 6 feet long. Okay? Morning. Thanks, too. Okay? Thank you. All right, the next one right here. The legs of a triangle are x and x plus 6, and the hypotenuse is 14 feet. Now, I'm asked to solve for x. So this one is a lot like the very first one that I just did. Okay, I'm plugging it into quadratic formula, and I'm going to work it out and combine like terms. Now this x plus 6 means x plus 6 times x plus 6. So this x squared plus 12x plus 36 equals, I believe that's 196. Check my math on that. Y'all have calculators lying around. Check my math on that, please. Y'all, please stop being lazy. Y'all are going to end up with work to do over Thanksgiving break because we got to get all this stuff done.
That's right.
Okay? Thank you. Y'all please keep talking to me. Right here I've got 2x squared plus 12x. And I'm going to go ahead and I'm going to move this 196 over. So I'm going to do 36, take away 196, and I get negative 160. And I'm going to take out a GCF. Right here, if I divide out 2, I get x squared plus 6x and then minus 80. See, I'm trying to think through my factors of 80, but rather than doing all that, I could just go to Desmos. You got x squared plus 6x minus 80. Okay, I get ugly decimals again, so that tells me it does not factor. What's the only one that's going to make sense right here? Yep, 6.434. Okay, and let's see, I'm going to say feet. I was only asked to solve for x. I don't have to go figure out that other leg length. I'm done. Sorry. Okay, so I scratched out this. I don't really need that. You would have to do quadratic formula here, but if I have Desmos, use that. Okay? Here's another one. The leg lengths of a triangle are x and 2x minus 3. The hypotenuse is 13 feet. It says solve for the lengths. So I want to know both legs right here. Okay, so here we go. X squared plus 2x minus 3 squared equals 13 squared. This means 2x minus 3 times 2x minus 3. So I have x squared plus 4x squared. I have minus 6x, so that's minus 12x. And then plus 9 equals 169. I'm going to combine those and subtract the 169 here. So that's 5x squared minus 12x, almost put a squared there, and then minus 160 equals 0. I don't really want to go through quadratic formula here, so I'm going to go to Desmos. You'll grab the door for Julie again. Okay, I got 5x squared minus 12x minus 160. Okay, what's the only one that makes sense here? 6.983 on your quiz, and I worked through my version of the quiz that if y'all will get your butt in gear, I'll give you my copy again. this time, but if you do not, I have the right to withhold that. Okay? This right here is one of my side lengths. What do I do to find the other? Plug it in. I'm going to plug it in to the 2x minus 3. So 2 times 6.983 minus 3 gives me 10.966. And those are my two leg lengths. Okay? All right, here we go. Rectangle area problems. Okay, it says the length of a rectangle is 4 inches longer than the width. So if I know the width, okay, I know that the length is 4 inches longer than that. If the area is 96 inches squared, find the dimensions. Okay? Well, if this is the width, then the length is the width plus 4. How do I find the area of a rectangle? Length times width. Okay? So I'm going to say that the area, length times width, is 96 equals W times W plus 4. I want one side set equal to 0. So while I'm distributing, I'm going to go ahead and set this side equal to 0. So I'm going to get two approximations for W because quadratics have two solutions. What is the only variable that Desmos recognizes? X. So I'm going to do x squared plus 4x minus 96. Okay, I only want the positive one. So I'm going to get 8 and what? 12. So the width is 8 inches. And the length is 12 inches. Notice I took the square off because area is two-dimensional, right? But length and width are just one-dimensional. So take off the squares of your units. We royally messed that one up on one of the last quizzes. Okay? All right, here we go. On this next one, the length of a rectangle is 3 inches twice 3 inches less than twice the width. The area is 77 inches squared. Okay. The length is 3 less than twice the width. So if I know the width, I know that the length is 2W minus 3. 77 equals W times 2W minus 3. So once again, I'm going to set it equal to 0 while I am distributing that variable of W. Okay, I'm not going to try and do anything fancy. I'm just going to type this into Desmos. I'm going to let Desmos do the hard work for me. Okay, and I only want the positive solution because that's the only one that makes sense. Right here, my width is 7 inches. So what does that mean about my length? What am I going to do with that? Plug it in. 2 times 7 is 14, and 14 minus 3, 11. Questions? Okay. All right. The next two questions right here, okay, I am going to use Desmos for, but I just worked through some of these questions in the practice quiz, okay? Right here, you are told that a ball is launched upward with a velocity of 64 feet per second from a height of 5 feet. The height after t seconds is this equation. I am going to type this equation into Desmos with an x. So negative 16x squared plus 64x and then plus 5. Now, right here, okay, this is an upside down parabola, okay, it's really skinny, but right here what you will see is that the y-intercept is at 5, okay, because that is where the ball is launched from. That is your initial height, okay? That is one of the questions on your quiz. Not that particular number, but this is where it starts, 5 feet above the ground, okay? It asks, how long will it take to reach 80 feet? Well, let's come right here. Okay? How long will it take to reach 80 feet right here? Why is Jeremy shaking his head? It won't. Its maximum height is 69 feet. Okay? Then it asks, how long will it take to hit the ground? I do not want a negative solution here. We don't go back in time. Okay? So right here, what I'm going to say is this one, this x-intercept, it's going to take 4.077 seconds to hit the ground. You're looking for the x-intercept. It hits the ground right there. Okay, and you're looking for the x-coordinate. This is your initial height, which was 5 feet. This was my maximum, okay? Okay, next one. A cannonball is fired from 4 feet with an upward velocity of 300 feet per second. It says find the time it will take to reach 950 feet using this equation. All right, let's see. I'm going to change this to a 300, and then I'm going to change this to a 4. Okay, now, notice right here I had to zoom out pretty far, okay? What I'm going to do, I want to know where is it going to reach 950 feet. All right, 950 feet, is that the highest point on my graph? No, okay? So what I'm going to do right here, I'm going to type into Desmos y equals 950. Okay? I'm going to type in y equals 950 because I want to see where is that going to hit. Okay? How long is it going to take that to happen? 14.738 seconds. Okay, in pre-calc we use 3 decimal places, so that's what I'm going to use here unless I'm told otherwise. Okay, when I type this in, okay, and I type y equals whatever, you're looking for those x-intercepts. Now I'm going to zoom in and see if it hits before there too. It also hits at 4.012 seconds. It might only want the first one, so that would be the smaller number, okay? And then it says find the time it will take for it to hit the ground. Do I care about the negative number? No. I only care about the positive time. And that is where it comes back down and hits the x-axis after it has been launched. Okay? So this is 18.763 seconds. You're just looking for locations on your graph that should be given. Okay? make sure that you pay attention to how I address that situation. Okay, I typed in y equals 950 so that there was an intersection. Okay. All right, here we go. Work and painting problems. All right, Pablo can paint a room in 18 hours. Pablo and DeAndre together can paint it in 12 hours. How long will it take DeAndre alone? All right, Pablo can paint the room, one room, in 18 hours. I don't know how long it takes DeAndre to paint that room. But I know that together they can paint one room in 12 hours. Okay? So what I'm going to do, I am going to subtract 1 over 12 minus 1 over 18. Okay, and I got to have a common denominator. What do you want to turn that into? Can't I do 36? If I multiply 18 by 2, does that turn that into 36? And here I can multiply by 3. So this is 3 over 36 minus 2 over 36. So 1 over 36. That represents DeAndre's time. How long does it take DeAndre to paint that one room? Get off your phones, please. It takes DeAndre 36 hours. DeAndre might need to find a new job. I don't really think that Pablo's that great either, if I'm honest. Really, I guess it really just depends on the size of the room. All right, Sonny can do a job in 12 hours less than Dakota. Together, they would complete the job in 10 hours. How long would it take each alone? Okay, Sonny can do the job in 12 hours less than Dakota. So this would be Dakota's fraction. Okay, now together you know that they can do that job in 10 hours. One job in so many hours, okay? Now I need a common denominator in order to put all these things or work with these, okay? So right here, I am going to multiply this by 10D, because I need the 10 and I need the D. And then right here, I need D minus 12 and also 10. Okay? Right here, I'm going to multiply D and D minus 12. Okay? Shut up, y'all. Grow up. We've been doing just fine. Don't let immaturity creep back in my room. Right here, I know that my numerator is going to be 10D. Then I have 10D minus 120 because I'm going ahead and I am distributing that. Here I have D squared minus 12D. Okay, I said something that probably was inappropriate, but I wasn't even thinking about it, guys. Grow the heck up. This becomes 20D, and then right here, I'm going to move this stuff over here because I want to keep my x squared terms positive. So right here I've got 0 equals d squared minus 32d plus 120. Okay, I'm going to type that into Desmos because I'm going to work smarter, not harder. Okay. Right here, let's see. If I get these two solutions, I have 4.338 and I have 27.662. All right. Which of those makes sense for this situation? Yeah, you're only going to use the 27 right here because if I plug 4 in, okay, if I plug 4 in, 4 minus 12, that's going to give me a negative number, and we don't do that job in negative amounts of time. So right here, I'm going to say that Dakota can do the job in approximately 27.662 hours. Okay, and that means Sunny can do the job in, you take that and subtract 12, that gives me 15.662 hours. That is what you're looking for. You're not looking for just the 27.662. Okay? All right. The boat and current problems we have already addressed, so I'm going to skip over that. Let's go ahead with our quadratic analysis with applications. Okay? All right. Y'all, this is going to take very, very little time, okay, because I'm going to be using Desmos to help me answer a lot of these questions. And these right here are questions that are on your quiz that I just worked through, okay? Hold tight for just a minute and then I'll let you go, okay? All right, here we go. Right here, it says, graph the following function using a utility and find the indicated characteristics. Before I do that, I want to factor this. What two numbers multiply to give me 10 and to give me 7? 5 and 2. Okay? So that tells me what my x-intercepts are going to be. Now, it is very important when you type this stuff into Blackboard that you put these in the correct notation. Right here, your x-intercepts are negative 50, comma, negative 20. If you have multiple x-intercepts, it wants you to write them as ordered pairs, and you have to separate them with a comma. Okay? The y-intercept here, you could type this in Desmos, but if I plug a 0 in for x, this stuff right here goes away, and your y-intercept is strictly 10. Okay? Now, this is where I'm going to go to Desmos, and I'm going to type in this very simple equation. I've got x squared plus 7x plus 10. Oh, it would help if I actually typed it right there. X squared plus 7x plus 10. I'm going to zoom back in because I don't need that much space. Okay, my question is, what is the vertex? All I need to do is go down there and find the vertex, and I'm going to write that as an ordered pair. That's negative 3.5, comma, negative 2.25. And your axis of symmetry is a vertical line that goes down through the x coordinate of your vertex. But it has an equation. It's x equals. So it's going to be x equals negative 3.5. If you do not type in the x equals, it's not going to give you full credit. But look on the system and see if it has the x equals out to the side and then the box. Okay? All right, Amelia, make a pass real quick and you can go. All right, here we go. I'm going to go change my equation up. I've got a negative 7, and I'm going to change this to a plus 12. Okay? I've got two x-intercepts right here. those two x-intercepts are 3, 0, comma, 4, 0. Now, when I am working on factoring that, remember, my x-intercepts come from the opposite. So it factors into x minus 3 and x minus 4. You can work backwards if you want to. What is my y-intercept here? 12. The vertex is going to be 3.5, comma, negative 0.25. What then would my axis of symmetry be? X equals 3.5. Okay? Now, both of these functions were parabolas that opened up. Okay? Both of these open up. What then does this graph have? Does it have a maximum or a minimum? A minimum. Okay? So any graph that opens up right there has a minimum point. Any graph that opens down will end up having a maximum. Okay. Now, this one right here, okay? This is given to me in what we call vertex form. Okay? So I'm going to type this into Desmos exactly like I see it. Okay? There's my graph. All right. I am first looking for the vertex. My vertex here is the ordered pair 1, 4. If I'm looking at this, if this is vertex form, I'm going to get my vertex from the equation. You want the opposite of what you see inside parentheses, and you want the same value for your y-coordinate. What then is the axis of symmetry? It goes through the what coordinate? So x equals 1. Your axis of symmetry you can find from your vertex. Okay? What is your domain of this function? That's the x values that are allowed. All real numbers. We need to say negative infinity to positive infinity. And then my range here. Okay? Do I have any part of my graph that's down here? No. So my graph, my range begins at the y value of 4, and it goes up forever. Now that 4 value is included because it's part of the graph. So that 4 gets a bracket. Okay? Then we want to know interval of increase and decrease. All right. So interval of increase and decrease right here, if I'm looking at my function, as I'm moving from left to right, what is my graph doing first? It is decreasing. So this is an interval of decrease, and then it turns and it increases. From left to right, I'm going from negative infinity to positive infinity, and that change happens at the x coordinate of 1. So it is decreasing from negative infinity to 1, and it is increasing from 1 to infinity. We read these graphs from left to right. Okay? Make a note right here to use the x coordinate of the vertex. That's critical. You will get it wrong if you use the y value. Okay? All right. Going to the next function. I got negative 2/3. Then I have x plus 3 squared minus 5. Okay, how does this graph open? This graph opens down. So therefore, we know it has a maximum point. Okay? What is the vertex here? Inside opposite, outside same? -3, -5. If you type that in Desmos, there is no way you can get that wrong. What is my axis of symmetry then? X equals -3. The domain, once again, is -infinity to +infinity because there's no break from left to right. And this time, my graph is coming from -infinity, and where does it stop? -5. Okay, so I'm going to say -infinity to -5, and that -5 is included. It's part of the graph. Okay? All right, tracing my graph from left to right. What's happening first? It's increasing, and then it turns and it decreases. Okay? Now, from -infinity to +infinity is how we're moving, and the x-coordinate of that is -3. It was increasing first, then decreasing. So my interval of increase, I'm going to say -infinity to -3. And then my interval of decrease, I'm going to say -3 to +infinity. Do not write to -infinity because it's pointed down. We are moving from left to right. Okay. Now, if you are given a graph, let's say you don't even have an equation, you should still be able to pick out all of this information just by looking at the graph. Where is this vertex located? -2, +2. What's the axis of symmetry then? X equals -2. How does the parabola open? Down. This function has a maximum of 2 at x equals -2. Okay? The function is increasing and decreasing. Now, this change happens. We're going from -infinity to +infinity. That change happens right here at the x value of -2. So what's it doing first? Okay, so -infinity to -2, and then -2 to +infinity. Once again, do not write -infinity right there. That's your end behavior, not your interval of increase, decrease. Okay? You do this one. Do the next one at the top of page 31. Y'all are so addicted. Worse than a drug problem. Seen a lot of my former students pop up on Housing County 411 the last couple of weeks.
Really?
Uh-huh. All right. See how you did. This one right here is the one I was mostly concerned about you getting. Okay? All right. Next. Down here at the bottom, I am asked to rewrite these functions in vertex form. All right, vertex form is this format. A times x minus h squared plus k. We need three things. We need a, h, and k. My h value is the x coordinate of your vertex, and your k value is the y coordinate of your vertex. So this is where Desmos is going to help me tremendously. Okay? I'm going to type in this function. Okay? I have x squared plus 4x minus 3. I'm going to go write down my vertex. Right here, I have -2, -7. -2, -7. And your a value comes from the number that sits out in front of that function. So my a value is 1. Now, if I go plug this stuff into my vertex form that I've got right here, my a value is 1. My h value is -2. And my k value is -7.
Students that when the bell rings, it'll be time for
I'm not done.
They need to go
Right here, this double negative becomes a positive.
Kelly, Dawn, and Taylor.
That is my vertex form.
Front office.
So you literally need three things: A, H, and K. You need A, H, and K. My A value here again is 1. If I go type this in, let's see, this is going to be minus 8x plus 7. The vertex is 4, -9. So when I go and I plug this into vertex form, my A value being 1 is not going to change anything. I'm going to have x minus 4 squared and then minus 9. Make sure you have those written down. Okay? Make sure you have your Chromebook charged and ready to go tomorrow. Some of you have had plenty vacation, so I highly expect to see you here tomorrow. It is possible for one class to work hard enough to earn this work of mine and others not get it. You need to be here and you need to do what is asked of you. Have a seat. Nobody's leaving till